Hi, welcome to our notes talking about average rate of change in systems of linear and exponential functions. Before we get started though, we're going to go ahead and write down the formula of finding rate of change. So this is a reminder. It is the change of y over the change of x, which is equal to y2 minus y1 over x2 minus x1. Okay. The increasing exponential function f of x equals 4 times the quantity 2 to the power of x is shown partially in the table below. Find the average rate of change over the various intervals given. So what we're going to do is, for problem number 1, remember it is going to be the change of y over the change of x. And so they give us our range from 0 is less than or equal to x, which is less than or equal to 1. So I know that my denominator is going to be 1 minus 0. So what I have to do is I have to go to the table and I have to look. Well, when x is 1, what is my y coordinate? 8. When x is 0, what is my y coordinate? That is 4. And I have the subtraction sign in there because it is a part of the formula. And then we just go ahead and simplify. 8 minus 4 is 4. 1 minus 0 is 4. So we have 4 for part A. Then for part B, it's the same thing, the change of y over the change of x. And so they give us the range, 1 is less than or equal to x, which is less than or equal to 2. So we know it's going to be 2 minus 1. Then we're going to go ahead and figure out when x is 2, y is 16. Carry over the minus from the formula. When x is 1, y is 8. Okay, and so 16 minus 8 is 8, 2 minus 1 is 1, so my answer here is 8. So let's go ahead and keep going for C. So for C, again, they give me the range for my x. It's going to be 3 minus 2. Okay, so when 2 is less than or equal to x, which is less than or equal to 3, then we find the corresponding y value. So again, when x is 3, the corresponding y is 32. When x is 2, the corresponding y is 16. And then again, we simplify. We end up with 16 over 1, and so we'll go ahead and just write that as 16. And then for the last one, again, for my domain, they're asking about the range from 3 to 4, so we'll go ahead and find the difference by doing 4 minus 3. We find the corresponding y, so that's 64 minus 32. 64 minus 32 is 32, and it's 32 over 1, and all we need to do is write down 32. Now the next thing that it asks about is the growth factor. And so the growth factor is how much in each of the, from 0 to 1, 1 to 2, 2 to 3, 3 to 4. Okay, here I went a little low. So from 0 to 1, I had a growth factor of times 2. From 1 to 2, a growth factor of times 2. And that's what we have from 2 to 3, a growth factor of times 2, and so on. And so you may be wondering, well, why do we have to show all this work for average rate of change? Well, you just need to be able to know how to do that, be able to know how to answer that our growth factor is 2, depending on the information given to you. You don't always get a nice table. You might get a graph, or you might just get ordered pairs. So just depending on the question, it's good to know how to do all parts. The next thing that we're going to do is graph the following system of equations on the same coordinate plane, and we want to know the solution. So real quick, remember, solutions are points of intersection. So what I'm going to do is I'm going to go ahead and jump to Desmos. So I'm going to go ahead, and here is Desmos, and I'm going to go ahead and enter in what I see. So I have f of x is equal to 2 to the power of x. So I'm going to go ahead and do 2 to the power of x. Okay, so I see that come up on my graph. The next one is g of x is equal to 3/2 x plus 1. So we'll go ahead and put that one in. 3 divided by 2x, oops, I want to make sure, there we go. The x is next to it, not as a denominator, plus 1. Okay? And so if you take a look at this on Desmos, we see that we have 2 points of intersection. Here's one. Oops. There we go. 0, 1 is one of them. And then our second point of intersection is right over here, 2, 4. So we'll go ahead and answer part A real quick. And when we do that, we get 0, 1 and 2, 4. Okay? The other thing for part 2 is it does say graph the following system of equations. So what I want you to do is go ahead and pause the video. And so when you pause the video, you can go ahead and pull this up in Desmos on your Chromebook. Sorry, had a brain fart there. And then you want to go ahead and take a look at the tables for each one, okay? And use these tables to help you graph each of these, okay? And so what I expect you to do this on your own. I'm going to be pausing the video so I can do it. And so same thing, you will be pausing as well so you can do it. So hopefully after you pause the video, you have a graph that looks just like mine. What I want us to do, because we are graphing 2 lines on this graph, is we're going to just label each line. So this one is going to be y equals 2 to the power of x. My other line will go ahead and label as y equals 3/2 x plus 1. So again, make sure you are doing that. Now, let's go ahead and jump to part B. Part B says, what is the average rate of change for each function over the interval 0 is less than x, which is less than or equal to 2? And so we're going to go ahead and do that for each function. I'm going to go ahead and start with y equals 2 to the power of x. So again, I'm going to be showing you how to do the work. We're going to be doing the work nice and neat, and I expect you to be doing the same for the notes and for your homework. So we'll go ahead and write down when x is 0, what is my y coordinate? So we can either look at our graph or look at the table. So if I look at the graph, since I have it right next to me, for my blue line, when x is 0, y is 1. And then the other one, for when x is 2, I see that y is 4. Okay? And so what we'll go ahead and do is write down change of y over the change of x. I'm going to do 4 minus 1. I said 1, but started writing a 3. We'll go ahead and fix that, make that a 1. My brain is working faster than I'm writing. And then for my change of x, it is 2 minus 0. So real quick before I go on, I want to remind you that you need to line up the ordered pair. So I have the ordered pair 2, 4, and right on top of one another, you'll see I have 2, 4, and then again 0, 1. So the ordered pairs do need to line up. Then we'll go ahead and simplify. We have 3 over 2. Now, for comparing rate of change, you can write that, leave them as a fraction as is. You can write them as a decimal, but no repeating decimals. Okay, no repeating decimals. So we'll go ahead and have that in there. Then we'll go ahead and do it for my next function. My next function, I have y equals, I'm sorry. Well, it's g of x, but same difference. It's y equals 3 over 2x plus 1. And then to find the average rate of change for each function. So there's a couple things that I want you to remember, and we'll write down in our notes, is that average rate of change for a linear function is equal to slope. Slope is always constant. And it is constant for linear functions only. So we can go ahead and write down our slope. Our slope is 3 over 2. It does not matter what range of numbers we are given for a linear function. Slope is always constant for linear functions. Okay? Let's go ahead and try C. So this time I'll use the proper notation. So they want to know the average rate of change for each function over the interval 0 to 3. We'll go ahead, proper notation, f of x, just being consistent, for equal to 2 to the power of x. When x is 0, we already know y is 1. Now we have to figure out when x is 3, what is y? So if I look up 3 and y, I'm right here. Okay? So it is 8. And so we're going to go ahead and do the change of y over the change of x. 8 minus 1 over 3 minus 0. Then I get 7 over 3. We can leave it as 7/3. We are not going to write a repeating decimal. I can rewrite it as 2 and 1/3 if I want. What we're going to make a note of, since it's our notes, for these exponential functions, average rate of change has increased because we have an increasing function. But really, the other key thing that it is different than our first average rate of change that we established with a different interval. Next, for my linear function, g of x is equal to 3/2 x plus 1. My average rate of change in the interval 0 to 3 is 3/2. Okay, so again, remember, slope is constant for linear functions. Okay, and we'll go ahead and we'll finish the rest of the notes together in class. So that's it for me today.